Thank you very much, and thank you for joining our talk today on making fake data generators for open source data science projects. My name is Jennifer Hall. I'm a senior data scientist at the NHS AI Lab, and I'm joined by my colleague Matthew Cooper, who's also a senior data scientist at the NHS AI Lab. So what we're going to be covering today, we're going to look at how we use fake data generators, why they're good for our projects, how you can implement a fake data generator, what is synthetic data, and our recent work on synthetic data. So first, the NHS AI Lab Skunkworks team. The NHS AI Lab is part of the NHS Transformation Directorate. It was formed to support the safe, ethical adoption of AI in the NHS, and it's made up of a number of programs, including regulation, ethics, imaging, and the Skunkworks team, which we're a part of. And the term skunkworks came from Martin in the 1940s, which looked at really short experimental projects, and that's what we do in the Skunkworks team. We focus on very small, rapid, agile experimentation, looking at direct applications with the NHS, with AI technology. We're a small team that's always trying to find innovative ways in which the AI can support existing solutions and help solve problems across the NHS. A big part of what we do is actually try to share our learnings from the experimentation that we do. And to do that, we publish case studies, and we also open source code. And a big part of sharing those learnings was the ability for people to interact with that code and actually understand how it works. And that's where the importance of actually being able to have fake data in our repos, so people could pass the data through the models, could interact with what we had built, became so important. And we saw that really with our first project that we open source, which was looking at patients who long stay in hospital, and we were actually looking at if we can predict at admission how long a patient was going to stay in hospital. So before we get too much into the detail of that, I'm going to share a definition of what we actually mean by a fake data generator. So a fake data generator is a dataset generated at random with the purpose of testing code. The dataset will contain the same number of fields and same data types as the original data, but will not replicate any relationships or patterns found in the original dataset. So for example, the data that was originally used to train a data science model isn't using this. And the fake data is generated independently of the original dataset. One of the reasons why we can't anonymize the dataset is because of, the dataset that we deal with is very sensitive. We're dealing with health data, so we can't really publish that. Even if we anonymized it, we would have to go through a lot of approval, and rightly so in terms of information governance, making sure that we've covered across everything by GDPR. By having fake data generators, it allows us to be a lot more open in terms of what we can share. Fab. So why do we need a fake data generator? Which kind of answers your question. So thank you for leading me on nicely to the next slide. So when Gloucestershire Hospitals applied last year about their idea about whether we can predict patients who can long stay. And when you say long stay, we mean patients who stay over 21 days in hospital. It was a really important problem that we knew that would affect other trusts, and that if that this project could really benefit other trusts across the NHS. Prolonged stays in hospital can be bad for patients, especially those who are frail and elderly. And there's one journal that reported that 10 extra days in hospital can be a deterioration of about 10 years, especially in patients who are elderly. So what we wanted to do was have a proof of concept which explored whether or not we could predict how long a patient was going to stay in hospital. And then from that, we can show that to frontline staff, and then we can look at how patients can have their care tailored and personalised, so they might not have to stay so long in hospital. And why this was needed was when we published the code, a lot of trusts started to reach out to us and saying, we have a similar problem, we'd love to try and interact with some of this code, but we can't. But as to your point, we couldn't share the data. So why we needed it was so we could properly test the code when the real data was not available. So we opened it up, and anyone can have a go and have a look and test what we had done. It improves learning and understanding as users are able to step through step by step and also understand actually how the data is structured in terms of data types, some examples of what would be there in terms of like string length and character length. And it also promotes transparency and is a really interactive way in which people just don't have to read the code, but they can properly engage with it and run it. So that's kind of the background and the context of why we're doing this and why we think it's important. And I'm going to hand over to Matthew, who's going to talk through a bit more about the practicalities of how you put one together.
Thank you. Thanks very much, Jennifer. So now we've sort of talked a little bit about motivations for why you might want to generate fake data. I'm going to sort of talk about some of the practicalities like we just mentioned. So we're going to start off looking at the key components that you might need if you're going to generate some fake data. And these are relatively straightforward. And sort of, I guess, by looking at the example that you've got here, which is taken from the long stayers work we were just talking about, they sort of read themselves off the slide, really. So the first one, obviously, is you need to know what columns you want to generate. And here we've sort of called that column names. So you need to be able to define exactly what columns you want to be generated in your fake data set. Going hand in hand with that, you need to know what type of data you want to go in those columns. So you don't want to just randomly put any type of data across all the columns. You need to specify, in particular fields, specific data types. Building off of that, for where you've got categorical data types, the fake data generator needs to know what the fake category options are, so you need to specify those as well. And we'll come on to sort of how you might do that and maybe the way you might do it. But in the sort of middle column, you can see that on the screen. And finally, obviously, you need to know quite how much fake data you need to generate. In our example here, it's tabular data, so it's the number of rows that you would produce. So using those 4 things, you can then go ahead and start to build out a fake data sort of pipeline. So again, pretty straightforward, but what you start with is, on the left-hand side, the number of rows that you're going to generate, and as well as the file name that you want to save the file down as. You combine that with the list of field names that we were just talking about, and together with those, you produce an empty data frame, nice and simple. So you've got a sort of empty grid that you're going to then populate with your fake data. Moving through to the second step, you start with generating your fake data in the categorical fields. So going back to our list of fake category options that we mentioned before, you go through and randomly choose a fake category option for each row in each column that you're going to generate the fake data for. Once that's done, we then move on to numeric and date fields, which again are just generated randomly. You might want to set a range for those fields, or generate them completely randomly depending on what your motivation of your fake data is. Once that's complete, your fake data is generated, so it's nice and simple. Building off of that, we want to share some of the best practices and some things you might want to think about if you're going to be generating fake data. These build on the things that Jennifer was mentioning a little bit earlier, but we wanted to emphasize them. So one of the key ones in terms of best practices is to try and ensure that any fake data that you generate is obviously fake. So that might sound like a bit of an obvious statement, but the point here is that the purpose of fake data is to test code, not to try and produce results that mean something. Particularly in the healthcare context, going back to your question from before, it's important that if someone picked up a data set that was fake, they couldn't look at it and suspect that it actually was patient data. That could be problematic. So it needs to be really clear that the data set, if someone opened it with no other context, having never seen the code or the project before, that it was fake and all its purpose was to test the kind of plumbing of the code, if you like. Related to that, it's, we think, important not to overcomplicate the generation of the fake data. So the idea, again, I'm emphasizing this a lot, is to test the plumbing of the code. So you don't want your fake data to try and replicate any of the relationships that are in the real data. It's purely there to feed through your code and produce an output to test that it all works. So it doesn't need to be any more complicated than just randomly populating the fields. And finally, again, you'll notice that these best practices are all sort of related. You need to be really clear in your documentation about what the purpose of the fake data generator is. So on the right, top right, there's a sort of snippet from one of our pieces of documentation, which might be a bit small on this screen. But it basically emphasizes what you should use the fake data for. So testing plumbing, testing code, working out how a piece of code works, and what you shouldn't use it for. So don't try and use it to produce model artifacts or predictions. Don't use it in real-world settings, and don't use it to try and test the performance of your model, because it just doesn't make sense. Related to that, let's move on to the considerations that you might want to think about. So things that you might want to bear in mind when you're generating fake data. So It should be noted that when we're really clear about this is that fake data will usually produce meaningless results. In some cases, most cases probably, so in classification models, predictions, forecasts, you'd expect fake data to produce results that don't make any sense. And again, that feeds into the meaning and the purpose of using fake data. It's purely practical, not to test performance. On the flip side, there is a bit of a balance between making data clearly fake and the output of your fake data generator still being understandable. So as an example, for all the categorical fields, you could just fill them all with completely random strings. But that might not help anyone with understanding what the input data set should be. So maybe a better practice, in the middle column there, you can see that for a column that's showing admission method, there's test admission method A, method B, and a null value. So that says to someone, here's the possible sorts of values you might expect to see in here. And likewise, in the date, which I think is on the sort of far right-hand side, the dates look like dates, but they're set really far in the future or in the past. So it's clear that it's a date, but it's not contemporary. So as Jennifer mentioned, Skunkworks projects that we produced within the team include fake data generators as standard now. And we've delivered a number of different open source projects which include fake data generators. So there's the long stay risk stratification one, which is the one we've been talking about here, which uses a tabular data set. There's a project that looks at bed allocation, so when someone gets admitted to hospital, where they should be placed and on what ward they should be admitted onto. So that needed fake data around hospitals and admissions. And then we've also done a project looking at CT scan alignment. It's a little bit of a different one from those top two, and needed images. The idea and the approach was similar, but we produced white noise images that were of the right size and resolution, so that, again, you could test the code, but without any results. It's worth noting, and going forward in this presentation, some alternatives that you might consider if you were thinking of using fake data. Fake data is just one way of getting data out to release alongside your code. So there are some alternatives. I guess we'll circle back to the question again, but you could use real data. This is really, really industry and sensitivity dependent. So for healthcare, this isn't an option, but depending on where you work, it might be. The next one is repurposing an existing open source data set. So you might find that you could go and find a piece of data that's already there that serves most of the purposes of what you need. Maybe has the same field types, some similar names, similar idea. You could take that and maybe wrangle it a little bit and use that to feed into your model to demonstrate how someone might use your code. And finally, which we'll come on to in a second, you could generate some synthetic data. This isn't straightforward and isn't a sort of it doesn't address all the problems that there are with fake data. But it's something that might be considered as an improvement on, pardon me, on fake data. So why would you use synthetic data? So the main problem, as we've sort of touched on in this presentation so far, is that fake data limits the capabilities of what you can do with a code release. It stops you from assessing model performance and understanding exactly how well the model works. So the big benefit of using something like synthetic data is that it enables users to understand how well your model works and maybe see a more realistic output from your model rather than just something that is a jumbled set from the fake data that you've put in. However, there's substantial challenges associated with fake data as well. So information governance is a big thing working in healthcare, and using synthetic data only mitigates some of the information governance challenges. There's still information governance associated with synthetic data. So if that's a problem with your real data, synthetic data might not solve it. The bottom two are kind of interlinked, so generating and evaluating synthetic data can be quite tricky, and there isn't really any standards for evaluating synthetic data, so it can be quite difficult to know if what you've produced is good or works or is appropriate. We in the Skunkworks team were interested in exploring synthetic data, and an opportunity came up working with the analytics unit at the NHS, and they were looking to undertake a specific project which needed a nice, varied, rich set of synthetic data. And us and the Skunkworks team supported them by developing a pipeline, which we're going to explain in the rest of this presentation, to produce data that met their needs. We used a synthetic data generation model called SynthVAE, which you can see the details of on the right-hand side, that was generated by the analytics unit. And we took that model and fitted it into a reusable pipeline that went end-to-end to generate and evaluate synthetic data. So again, this nice sort of approach diagram. We started, this was kind of what we planned to do. So we wanted to take an existing open source data set, so using that concept that I mentioned earlier, we ideally wanted it to be healthcare oriented. We were going to pre-process it into a structure that was useful to us. We were then going to take SynthVAE, that's the synthetic data generation model, train it, generate some synthetic data with it, And then the biggest and I guess most substantial and useful part was we were going to take a range of existing metrics for evaluating synthetic data and put them into a report that reported on privacy, quality, and utility. And the output was going to be the synthetic data, a report, and some nice visualizations to summarize what we found about the data. So in terms of sourcing training data, there's obviously loads of data sets. SynthVAE was originally sort of created using the PyCox support data set. They wanted, in the analytics unit, they wanted more categorical columns and more date time fields. So we chose Mimic3, which is an open source intensive care unit electronic health records data set from the US. On the right-hand side, you can see sort of like a diagram showing how it's structured. The size and variety of Mimic3 meant that we could create a single file from lots of different tables. I think there's about 25 tables within it. So we could pick and choose exactly what we wanted to get a data set that fitted our needs. I then wanted to touch briefly, before handing back to Jennifer, about what the model looks like. So SynthVAE, as the name suggests, is a variational autoencoder. I won't dwell on this for too long, but the way it works is you put an input into it. You train the weights in the encoder and the decoder, which creates a latent space. And you initially train the model to try and reproduce your input data. And then you can feed in random data at the input, and that produces output data that looks like your training data originally. So I'll now hand back to Jennifer to talk about the evaluation stage of the project.
Thank you, Matt. So I'm going to talk about how we evaluate synthetic data. How do we make sure that what the output is looks good? And we classify sort of the evaluations to three different concepts. So we have utility, quality, and privacy. So utility is about what the data is actually going to be used for. So we need to think about what the purpose is. Is it going to be data that we're going to give to someone who wants to try and get insights in terms of correlations between different variables, or is it someone who just wants to test whether data can flow through an app? So there's different levels in which the quality is needed, which actually feeds into the next one, which is about quality. And is the synthetic data a good enough representation of the original data to do the work that we want to do? So how much ground truth is still in that synthetic data? And I'm going to talk a little bit more about some of the tests in a second, about how we actually look and measure some of the quality. And the last one is privacy, which is, again, incredibly important, especially in healthcare. So how do we make sure the synthetic data isn't giving anything away of the original data? How do we make sure that there's no leakage in terms from the original data set? And it's particularly important, so who's going to have access to that data set? And I think to the first question, if is it going to be open to everyone? Are you going to have to go through some kind of approval process to be able to access that data? And there's all these things that we need to think about before actually generating the data. And here are some metrics that we actually included in our synthetic data repo. This isn't all of them, but this is some of the high-level ones. So we have things like collision analysis. So we look to see whether the rows in the synthetic data set are appearing in the real data. So we make sure that the data is matching or not matching, depending on your purpose. We also have correlation analysis. So we look at how different fields within each of the data set are correlating. So make sure that, for example, if you wanted a high-quality data set, that you make sure that the correlations are very similar between fields and variables in each data set. We look at the Gower distance. So we look at evaluating the Gower distance, and that's looking at how similar the data sets are. We look at principal component analysis, and that helps us to understand kind of the patterns in the data and the different groupings and the variance. We also look at propensity testing, and that's when we combine the synthetic and real data sets together, and we do a very simple model in terms of predicting who's in the synthetic data set and who's in the real data set, and see how well the model can distinguish between those two sets. We have very high-level statistical distributions, so like means, average, and data distributions as well, just to get an overview in terms of what's going on in the data. As well as included, we actually used SDV, which is a really good Python package. It's the Synthetic Data Vault. In this package, there are various models that you can use to synthesize data, and they also have their own valuation function, which we incorporated, which has even more tests, and they've got loads of information on their website about those tests and how to use them. So I definitely recommend checking that out if you're interested in synthetic data. Yeah, so in terms of what we do with that, so we haven't actually published any synthetic data from our team, but if we were going to look at privacy checks, that'd be absolutely one thing that we would check. And we would have to make sure, in terms of like, information governance, who can actually access that data. So yeah, so we'll absolutely make sure, that that's part of the collision analysis, is that we would make sure that records wouldn't be appearing in the synthetic data that were in the real data. And there's also a range of other privacy techniques that you can do that the analytics unit in the transformation directorate are actually exploring as well. So Matt talked through how we got the data. We've now synthesized the data. We've now checked our data. And now it's all about joining it up. So how do we join it all together? We used a package called Kedro, which is an open source Python pipelining tool. And the reason why we did the pipeline is because we wanted to make this as reusable as possible. We do want people to use the code and interact with the code, and Kedro offers us a good way to make the code reusable for people who are interested. So you can see the pipeline here that Matt spoke through a couple of slides ago, and you can see that Kedro encompasses sort of the middle part, so looking at the pre-processing of the data, the training, and the evaluation of the data. Kedro allows us to have a config file, which is important, so the user can set their own settings and know where to set their settings, and none of that is buried in the code. That can be adapted by the user. We also have smaller pipelines, so if you just wanted to run the evaluation pipeline, because you have your own model, you can do that. Equally, if you just wanted to run the training of the model, you can do that as well. So Kedro allows us to be quite adaptable in that sense. You don't have to run the whole pipeline. And the whole pipeline can be run with just one line of code, which makes it incredibly accessible once you have the data. It also allows us to visualize the pipelines, and I think that's really key in terms of understanding what's actually happening in terms of a learning tool as well, that you can really interact with that. And Kedro Viz is really helpful to really understand where the data is flowing and where. And Matthew and I both worked on this project collaboratively, and having a framework like Kedro allows us to join up different parts of our code really easily and managed to make it flow really well. So where are we now? So we have a case study already released on our website, so please check that out if you're interested in finding out more. We are going to be open sourcing our code very shortly, so please check that out when that's ready. And SynthVAE is currently being developed by analytics unit, and one of the PhD interns is currently looking at that. So please keep an eye out for more exciting updates. I'd like to thank you for joining our talk today and taking the time to listen to us. If you'd like to find out more information, please visit our website. Also, if you have any questions, please feel free to email us. But thank you very much.
Do a bit of Q&A?
Yeah,
please.
Yeah, thanks. Very great talk. I have two questions. First, in the fake data, and not for actually training models or anything, just for evaluating whether your code works. I know that from personal experience that healthcare data has lots of missing data, so drug administrations or times where someone isn't being checked. Do you accommodate for that in building fake data? If so, how broadly? And the second question is, when you're building synthetic data sets, how do you kind of match up the statistical properties of with the data set without giving away too much of so how do you control how much of the original character of the data set you capture in your synthetic data? How can you sort of go about tweaking it so that you make sure that you can give away just enough to get the job done, but not too much?
shall I take the first one?
Yeah, sure.
I'll take the first question and Matthew take the second. So the first question about missing data. So what we do in the repo, and you can have a look at the long stay repo as an example, is that we have a JSON file that's got some example categories in it. And in there, if you wanted to, and some of the data that we had didn't have extensively, but if you wanted, you could put missing values or null values in one of those examples. And then what happens is when the fake data generator is being generated, it will literally just take a random sample of each of those different categories. So you would have missing data. If you included it in your list for that particular field, the missing data will appear, and that's when you can experiment in terms of how the code would deal with missing data. And you can adapt that to however you want it to be. So if you wanted to see what would happen if I put a number in a string field, for example, because that sometimes happens, you could do that, and the fake generator would read from that list, put in the number, and then you can experiment with that. I'll hand over to Matthew for the second part.
Yeah, so the question about I guess it's one of the big challenges with synthetic data is that balance, and that's what the privacy, quality, and utility kind of questions about. So I think there's always the challenge of, if you want the data set to be as open as you can, you're going to have to sacrifice quality and utility, because what's kind of central to quality and utility is that reproducing the original data set really well. You can help to minimize the risks by doing things like collision analysis and the Gower distance. So you can, if you're seeing in your statistical test and the other metrics that it's a good reproduction, but you haven't directly reproduced records, or you don't have records that are really close to the original records, you maybe could have a conversation about whether or not you're satisfied with that. But it's really, there isn't one answer of this is what you do, and this means that you get a really useful data set that will get past all of the, will meet all the required approvals, regulation, etc. It's a really open question. I know that doesn't really help necessarily, but it's a balancing act. At all times, you need to speak with the stakeholders to understand what's important, what isn't important, and then make a decision about what the outcome should be.
Sorry. Do you have a need? That was really good. I really enjoyed that. Sorry. A need for a step where, like, production data is always pure filth. People have smart quotes, for example. People have pasted from their case notes the smart quotes in Word, and everyone's waiting for the app to go live, and it blows up because it reads a smart quote and 500 errors. Do you have a step or a need for that kind of injecting those, data gremlins or horribleness in the data?
Yeah, I know exactly what you mean. I think so. At the moment, we don't do that with fake data, but I think it could be a useful extension. Although I guess it depends what you're using the fake data for. If the intention is to stretch, to try and test that your tool works for all different sort of edge cases like that, I guess, then you could adapt your fake data generator to do that. I guess the angle we were coming at it from was putting some data out there that demonstrates how the pipeline works end-to-end broadly, so that someone could go away and use it. So in our work, we probably don't really have a need for that at the moment, but I can definitely see where it would be useful for sure.
Hi, thanks very much for your talk. I was just wondering how well the synthetic data works in terms of if you have lots of data across different tables, like in CPRD and data sources like that, how well does it preserve those sort of like inter-table relationships between events and like patients or whatever?
Yeah, I think it really depends on the model that you use ultimately. The model that we ended up using performed okay. Again, I think it comes back to this privacy, quality, utility sort of balance, in that if you want it to really preserve the balance of, preserve the relationships across those tables, there's sacrifices to be made elsewhere. And there's definitely some models that do it better than others, whereas there's other models that prioritize privacy and maybe sacrifice that balance. So I think in our case, it performed so-so. Yeah.
Thanks.
Hi, thanks, very great talk. About the data itself, what were you able to use it for other than predicting bed allocation, I think it was, and length of stay? And more as a sort of policy question, second part of the question really, how futile is it to be working on something like this, considering that at the end of the day, it's just lack of funding for the NHS? And as in, so to reformulate that, were this to be fully automated and were it to be like really smooth, you know, is sort of the NHS being dragged through the mud? How much is this going to help, basically?
So I think there's definitely a place for fake and synthetic data anyway, broadly, not just in the NHS generally, because it improves accessibility to data that might not otherwise be available. So I don't think it's, I think it's a good use of time and effort because it improves access to all sorts of things. Like, for example, on the long stays project, we've got a data set internally we've been working on, but we couldn't release that because it's patient records. So it improves accessibility to what we've done from other trusts who have their own internal data sets that they could work on. But if we just release the code, maybe they wouldn't know exactly how a field was generated or exactly the name of a field. It's a fairly basic example, but that would help to improve their understanding. I don't know if that answers your question necessarily. I think it is a useful use of our time, and we've had good feedback on providing fake data. We did do a few projects where we didn't have any data with it, and the feedback was, we're not too sure how we can run this. So by doing that, we feel like we've added an extra element to our projects.
Hi. Apologies, I missed the beginning, so sorry if you did already mention this. Have you come across the privacy-preserving GAN approach to generating synthetic data?
I think the analytics unit have tried that. I know that the SynthV model had a differential privacy feature that was built on it. We didn't use that for this because it was sort of a bit more of a proving the end-to-end side of things. But I think a big part of a useful next step in this work would be going through and looking at how different models performed in this kind of setup, so that you could maybe use the evaluation report to compare the outputs from different models for the same data set, across-wise. That isn't something that we've done here, but I think a framework like this would provide a way of comparing those, so looking at how the privacy's been preserved from the GAN versus SynthV as an example.
Yeah, it does seem a bit too good to be true because it's going to learn the trends from somewhere. But the promise of that paper, this was back when I was doing accelerometer-based tracking of data to see if we could detect gait an abnormality, is you could generate as long as you want amount of data that has all the traits in it and preserves privacy. It's like win-win-win. Theoretically, I'm a bit of a skeptic on this. I feel your pain. I did some stuff with the Scottish healthcare data, and I had graphs that I would love to show people, but the n was less than 5, so I couldn't. I was like, this is so irritating that I can show you the events of kidney failure, but I can't show you the graph. I can just say that I can do it. So it's a very frustrating thing. One other follow-up question. Is there a point where the ethical consideration is outweighed by the need for doing good? So you might have something that breaks the privacy, but it is valuable to do it. I'll give you my example from, was it 23andMe? They discovered a 100% penetrant variant of Huntington's disease because somebody had an absurdly long repeat sequence that even their really insensitive scanning came up with it. And they were like, but we don't have the patient's consent. It's not a patient, but the person's consent to tell them that they have Huntington's disease because it was an absurdly wrong repeat sequence. Is there a point where this would outweigh that?
I think it's quite a difficult question. And I think, I don't know is the answer. I don't want to pretend I know the answer either way. I think if something like that came up in our work, it would be a conversation to have with the people who work on ethics within the AI lab and on regulations and all that sort of thing to understand what the best path would be. I guess it could be something that came up, but it's not something we've encountered.
Thanks very much.
Thank you for the talk. I would like to ask a bit about the role of fake as opposed to synthetic data. So is there a particular use case where fake is superior other than privacy limits us from using the other kind of data? And also, as a follow-up, do you think there is a place for manually generated data or partially manually generated data combined with random inputs, maybe?
Do you want to take that one, John? I couldn't really hear it.
I'm sorry, can you just repeat the question, please?
Yeah. So when do we want fake data as opposed to synthetic data? Is it just when privacy prevents us from using the other one, or is there any other case?
Oh, yeah, thank you. No, that is a good question. So at the moment where we are with synthetic data, there's still so much more we need to understand, especially around privacy. And like I mentioned, the analytics unit is doing quite a lot of work in this at the moment. And that's kind of the reason why we have that separation between the synthetic data and the fake data. The fake data has never been exposed to the real data set. Any patterns in it are completely random. It's generated every single time that someone runs it. And that way we can be fully confident that there's no privacy because it's not real data. It's just, there's nothing in there. Whereas with synthetic data, to someone's point earlier, there is potential because it has seen the real data. So for us at the moment, the fake data allows us to publish. With the synthetic data, there's still so much more we need to understand before we can start maybe interchanging them. But there's so much more work that needs to be done before we can start publishing it or given access. We're just not quite there yet. So that's kind of the difference. I hope that answers your question.
Any more? A few minutes.
Hi, Nick Radcliffe from Stochastic Solutions and Smart Data Foundry. I wondered if I could add a response to that, actually. I was working in synthetic data. I guess the other case where I'd say that fake data, as it's being described, can be superior is when what you're primarily doing is testing robustness of software, because it's much easier to put really destructive, massive outliers, really bad data and stuff. I mean, you might think that real data sets and the NHS data and so on is bad, but you can put even worse stuff in fake data really easily. So it's the same as the sort of fuzzing approach to testing software. So that's the other case where I'd say it can literally be superior to use fake data.
Thank you.
Thank you, Nick. Okay, so we've got maybe 1 minute. I don't know if you wanted to have any closing thoughts or maybe...
There's a couple more questions. Do you want to try and grab those guys?
Just a very quick question. So I like that when you show that the metric you are using, there are many of those, probably are more. I'm wondering, if you're not satisfied or you want better stuff, how do you handle this with your model? Just you have to change model, or just you play with the parameters? Because I think you should just show one model, but you plan to have more of them, or you think that is enough? It's just playing with hyperparameters or something, or?
I might hand this one over to you, Matt.
Yeah, so I think what we're going to be publishing uses one model, but there's nothing to stop you going away, and because it's written in Kedro, you could go and adapt the code, say, okay, I want to see the output of this model, but also I want to run it with another model, and that would enable you to compare like for like. I think the intention of the pipeline is to kind of show a high-level overview of how good the synthetic data is that's been generated. And if you weren't satisfied, you could maybe go away and do a bit more analysis to try and understand exactly where the problems are, because some of the metrics and the approaches give an idea of the problem, but might not say, okay, the problem is in this field, or et cetera, et cetera. So I think going away and investigating then might inform you whether or not there's hyperparameter tweaks you could do, or choose a whole other model altogether. Hopefully the pipeline enables that swapping in and out to try and help you get the best result that you're after.